Hello community! Now you remember in my last video in the Outlook I told you, hey, maybe we will have a look at Microsoft AutoGen, the multi-agent conversation framework. And here we are, here we go! And since it was so boring, as in mid of August 2023, Microsoft published the AutoGen, nobody watched this particular research publication because everybody said, hey, this beautiful video on the channel Code Your Own AI. And here I showed you how you could code a single agent. And later on, where are we? Let's say about here. I showed you how to code multiple agents. And going a little bit deeper, I showed you here, let's stop here. Here, task specialization, we have a control agent, we have multiple agents, and I showed you how you can code multiple agent interaction with parallel processing. And this video was such a success, but you see here, this video was published on June 25th. So when Microsoft came out in August, a month later, this was already some old information. Now, let's spice it up a little bit, storytelling, let's make it more interesting. So what we say? Interestingly, a month later, 1.5 months later, now the management of Microsoft came together and said, hey, the bonus of our CEO is not high enough. We have to generate more profit for Microsoft. How we do this? Well, you know, it was tough, but they decided to increase here not only the prices, but also write a new program that would provide them with 100%, 200%, 400%, 500% more profit. And they decided, and it was here in September 25th, 2023, to launch AutoGen again. But now with the full marketing, and now we have AutoGen, ladies and gentlemen. And we have here the CEO of Microsoft saying it is the best thing ever happened. Oh no, wait. It is the most exciting development I've seen in AI recently, says here the CEO of Microsoft. No, it's not the CEO of Microsoft, the director of AI. No, it's not the director of AI. The head of finance said this. Okay, this would be true. So we take here a technical fellow who says this is the most exciting development. And if you want to know the technical fellow, here's Doug. This is our technical fellow. And you know you can trust Doug because he is passionate about innovation, committed to deliver, and currently all in on AI. And you say, okay, this convinced me. So now I want to have here AutoGen in my life, and I want to pay Microsoft multiples to use AutoGen. Welcome to this video. So if we look at this, you know, it is rather easy. So what was the idea of Microsoft to generate more profit? They said, hey, we have agents. And what is an agent? An agent is GPT-4, or an agent is code interpreter GPT-4. So we want that multiple agents, so multiple LLMs where you have to pay Microsoft Azure to interact. So we have here a beautiful money generating machine. So they have here this official notebook here and they say how we do this. Now, the first thing was easy. We have to have a lot of agents, and every agent is an LLM you have to pay for. So we say, hey, we have here GPT-4. Then we have GPT-4 0314. Then we have GPT-4 32K token length. Then we have the 32K token length on a specific date. And then you say, okay, but what about here the version 0314, you know? And you can go on and you can add here the code interpreter, and you can add here some specific LLMs that Microsoft Azure offers for its shareholders, for its clients, of course, who thinks about profit for shareholders. So you have a lot of different models available for you. And you know what? If we go further here in the code, you see here, open please here your credit card. Open here your API key here. And then for your Azure OpenAI API key, please insert your credit card here multiple times for each model. So we have here the OpenAI API endpoint for GPT-4, and then we have the Azure OpenAI API endpoint for GPT-4, and we can go on. And you know what? The good thing is you can put in multiple keys here in this, and this is beautiful. As you can see, we are into multi-agent programming. Now, isn't this fascinating? And this is the code by Microsoft, so thank you, Microsoft, for helping us. Now, if we are here a little bit on the scientific side, and okay, it's Monday, so let's do a little bit of science. You might say, hey, come on, buddy, let's do this in the right way. So we have to go to GitHub, we go to Microsoft, AutoGen, and then here, let's have a look at here the mathematical utilities, the Python file that defines here the mathematical utilities for our multi-agent operation. And as you know, this is real complex code. So let's have a look here at the explanation. So we define here a function and we call it solve a problem. And you might say, hey, Microsoft, cool. So we have the problem statement and this is a string. And the output is a string. And you say, this is interesting for a mathematical formula in a string, but never mind, come on, it's Microsoft. So here we are with the arguments. The input is the problem, the string. And remember, our agents are LLMs. So we have here beautiful some English sentences here that define the problem statement. Please calculate here the area of, I don't know, a rectangle or a square. And then we have here for the communication between the agents, we have to have here a communication protocol. And you remember in the good old times, we had here our APIs. And so we say here, hey, here configured your API call. Congratulations. This is it, because this returns now the solution to the problem. So you see, this is everything here for a solver function. It is as easy as you can imagine. So if you just have some complicated text, do not be intimidated. It is sometimes so easy. But you say, hey, now the agents, no, there are multiple agents and we have a coordination agent and we have trainable agent and this must be extremely complicated. And you are absolutely right. Look here. We have here an agent. We have an assistant agent. We have a conversable agent. We have a group chat and we have the boss, the user proxy agent. This is the CEO of Microsoft. This is the head of the team. This is, if you are in a conference room, this is the person who is talking, who is deciding who is talking after him, and who may raise his voice in the meeting. So here we have it. So let's start. Let's look at the general definition of an agent. Then let's look at the assistant and conversable. And then let's see what is the power of the boss doing. So remember, agents are LLMs, or if we then go later in this video to vision transformers, LLMs and vision transformers, or maybe also with audio LLMs. So let's start. Let's start easy. AutoGen is simple. So we have here the class of an agent. And you might say, brilliant, brilliant, amazing. So what is an agent doing? An agent, let's make it a little bit bigger. An agent can communicate with other agents. And you might say, breathtaking, breathtaking, Microsoft, and perform actions. So, of course, since every agent we are allowed to pay Microsoft, we have multiple agents in our scenario, and say different agents can differ. Yeah, otherwise you would pay for the same agent. So there was some genius coming up in this meeting, in the marketing meeting at Microsoft, and say, hey, different agent can do different actions. Like expert system. And they say, wow, this is it. So different agent can differ in what actions they can perform and they receive something. And you say, breathtaking, breathtaking. So what is here? If we go now here, a deep dive in the code, and I love code because it tells you everything about the system. So here we have the function name. Get the name of an agent. Great. Then we have here send. Send a message to another agent. Breathtaking. And then hold on to your chair, because then we have receive a message from another agent. And you say, now it's getting really complicated, yeah? And then we can reset the agent. And you say, this is amazing, and this is here an agent. And you say, wow, this is okay, this is the general agent. But now let's have a look here at the absolute specification of an assistant agent. And now you can see, wow, now it's getting complicated. Now, hold on, because now we have a deep dive. An assistant agent is designed to solve a task with an LLM in the background. Or itself. If it's an LLM, the agent, it solves the task by itself. So an assistant agent, and please note now a subclass of a conversable agent. So here, the next thing here, the conversable agent, gonna talk about it in a second. And here the assistant agent, here's something special, is configured with a default system message. And the default system message is designed to solve a task. And you say, unbelievable. Including suggesting Python code blocks and debugging. And yes, you get it. This is here the case where we have GPT-4 on Azure interacting with GPT-4 code interpreter on Azure. And you can pay for both systems. Congratulations, this is it. Now, you are amazed, I knew this. So, the agent doesn't execute code by default and expects the user to execute the code. So, okay, the agent is a little bit, I says, why should I work? Hey, user, you execute the code. I just give you the code. Okay, so we have to decide. Code, we have code generation, and then we have code generation and code execution. So assistant agent only generates the code, but does not execute the code by default, and expect we here, the user who pay Microsoft for this task, to execute the code. And now you might say, my goodness, now here the prompt engineering, here this must be the mastermind. So let's have a look and learn from the best here. So we have the default system message, and remember we have here a system message. This is what defines our assistant agent, and here we are. And we go, you are a helpful AI assistant, and this blows your mind. No, I mean, this is genius. But solve tasks using your coding and your language skills. In the following cases, suggest Python code, as we just learned, just the code, not the execution, or a shell script for the user to execute. So you get a message by the human, and you have to find the right Python code. How we do this? Solve the task step by step. You know this beautiful step by step. Nice. If now a template or a structure or a plan is not provided, how you should proceed? Create a plan, explain the plan, and be clear with step of the steps you use here. Yes, user cannot provide other feedback beyond if you want the user to save the code in a file before executed it. Insert the code block as the first line. If you find an answer, verify the answer carefully. This is something that we can improve significantly upon, maybe in the second half of the video. Include verifiable evidence in your response if possible, and reply. Terminate in the end when everything is done. So, system comes in, well done. Default system message for this particular assistant code, the assistant agent, says, hey, you get the request, you generate the code, and you will have done generating the code. You say, hey, I'm done, I'm ready, ciao, the next one. And this is the assistant, and you say, it is amazing. Now, in the arguments, it's a little bit more interesting. You remember we have here the API as our communication protocol, or our open API, or if you're older, Swagger, or whatever you like. So you have the system message. Great. Then you have the configuration. Yeah. And then you have here a specific function that takes a message in the form of a dictionary and returns a Boolean value indicating if the received message is a termination message. So we have here keys, specific keys defined. This is the content, this is my role, this is my name, and this is the function call. Function call, remember, OpenAI 3 months ago. And this is it. This is an assistant agent. As you can see, easy. We are working with LLMs. We can define here their ability here simply in English. And then, as we learned, here now we have our conversable agent. What is a conversable agent? Let's make it even bigger. Wow, this is a little bit too big. Wait a second. Can we make it smaller? Yeah. A conversable agent is a class for generic conversable agent, which can be configured as assistant, we just had the assistant, or a user proxy. User proxy comes up. So we have here a super class, and we can divide into an assistant class or a user proxy class. Now, it's all over again, but the interesting part here of our conversable agent is after receiving a message from somewhere in the pool of our agents, the agent will send a reply to the sender unless we have a termination. For example, assistant agent and user proxy agent are subclasses of this class configured with their default setting. My goodness. So you see, this is just more or less an empty shell. We already saw what we can do here with our assistant agent, and now we go here to the user proxy agent. Now, we know now, user proxy agent, what is it? Is a subclass of the conversable agent configured with some human input code. So this is the agent, this is here GPT-4 talking to the human. This agent is allowed to talk to the human user. Wow. And always has LLM configures false. The agent, the main task of the agent is prompt for the human input every time a message is received. Code execution is enabled by default. LLM-based auto-reply is disabled. And you can modify everything. Beautiful. What we have here, the arguments, more or less the same. So whenever we have here the human that says, hey, stop it, or hey, continue, or hey, focus now on this element, we have inputs by the human. We say that we have recognize it, we terminate it, never prompt for human. So how the human is in the loop is here more or less defined here with your user proxy agent that communicates here in the network of agent with the human part. Great. That's it. So now you can see we have here our general agent, our conversable agent, and the two subclasses of a conversable agent, the assistant agent and the user proxy agent. And as you find out here, what is group chat? Now all the agents, they have to talk to each other because, hey, this is AutoGen. So generate some agents that are able to communicate with each other and solve a task, given their specialities or their specific task abilities. So what is a group chat? A group chat class that contains a list of agents. So you say, oh, this is now here the coordinator. He knows how many agents are within my group, and he knows here how many rounds, if you say at first we have agent 1, then agent 2, then agent 3 can talk, how many rounds we are allowed to do in our group. Great. Now you see, you can put in a template here that you say, at first I want agent 1, then agent 3, then agent 5 to talk, and then we get the result of those 3 agents, and then agent 4 and agent 2 will also contribute, and then we come to the conclusion. So however you define here the structure when each agent is allowed to talk, this is it. You can select a speaker, select the next speaker if you have GPT-4 as your main intelligence. Here you need a huge, powerful LLM system that understands that now agent 3 should talk and not agent 2, given the specialities of the different agents. So this speaker selection is important. Self-message system reads the above conversation, then select the next role from the list of the all agent to play. So you have a recorded conversation, this group chat intelligence, if you want, can select the next speaker based on the conversation that happened in the past, on the results that we already achieved within the group, and then select the next agent on the list of the agent who can now contribute to the discussion of the agent. So this here is our mastermind. This here is the one who controls who is allowed to talk in the group. What we have here, register, run a group chat. Yes, initiate the group chat, append the group chat. Beautiful. Keyboard interrupt. Beautiful. The speaker sends a message without requesting a reply. Last message. Speaker, done, finish, group chat. So you see, this is the code here from our AutoGen, Microsoft AutoGen agent chat, group chat. So whenever you approach something new and you want to get an idea, have a look at the code, because the code tells you what is happening and you see the complexity of the code, how it is structured. And yes, in my video here about multi-agent reasoning more than 3 months ago, I already showed you this here in a complete coding example. We did more or less exactly the same, but of course I used here from OpenAI here the conversation agent, it was called, and not the group chat super user agent. But you see, this was already known when this was published by Microsoft. But now Microsoft, as I told you here, September 25, hey, now we need to make some money, so let's run this. And you know, they are so beautiful. You know why? Because they tell you, hey, no problem. We give you here all the different possibilities how this is coded. So they give you here a Colab notebook and I say, hey, what about solving a task with coding and a planning agent? So you have GPT-4, you have GPT-4 code instruct, or you have whatever model you want to pay for, whatever model LLM, coding LLM is available somewhere on the internet and has an API. So you can go there, pay for this system, connect it with the GPT-4 system on Azure, or load some agents into Azure, pay Azure, and you know what we are talking about. So as I told you, you have here your credit card ready. You can construct agents the way you like it to give you here, make it even bigger, okay? You know now what is in AutoGen an assistant agent. You have seen here the default configuration. Now we give it a name. We call now this agent planner. The configuration list you can define here. And you can even override here the system message, what you are. And you say here in a breathtaking new innovative approach, you are a helpful AI assistant. Well, you suggest coding and reasoning steps for another AI assistant to accomplish the task. And then we generate here from AutoGen our user proxy agent, and we give him the name planner user. A little bit strange name, but okay, never mind. Human input mode never, so he's not talking to our human. And then you simply define here the group chat. You initiate the chat between the participant, planner, and planner user. Okay, we construct now the assistant agent and the user proxy agent. Well, create an assistant agent. We name him assistant. So again, from AutoGen, assistant agent. And then we have now the configuration. So you can define the temperature, the timeout, yes, the model, what you pay for, everything. The name is now Ask Planner for this one. This is the description. Get a plan for the finishing task and then verify the execution result. Great, unbelievable. The type is string and this is it. And then we create a user proxy agent and we call him user proc. You see, it's always the same. So we have defined our agents. And now we say, hey, let's perform a task. Unbelievable. So, and now here, all the agents starts to come alive and your credit card says, hello, I got a lot of requests from multiple Microsoft accounts. You are lucky. So here we go. User proxy, initiate the chat, start everything. activate our assistant, and the message is, the task given here is to the group of agent, suggest a fix to an open good first issue of Flymon. Great. And now you can see, it starts to run. Python code is generated. Auto reply encoding, yes, something. Assistant comes back, says, hey, I did this. And then we have the planner user, yes, and then we have here, and you pay for each token. You notice you pay for each system. Remember, this is the general plan, and then we have here from the user proxy to the assistants, here the response here. Yeah, let's do this, then do this, then do this, then do this, then do this, and then we pay for everything. And if it's a smaller task, we should pay for this and this and this and this and this. So you see, this system starts to run. And if you say, hey, only 5 cycles, you will have 5 complete cycles that you pay for. And you see, this is here the power and the beauty of Microsoft AutoGen. Now you're amazed. Let's do a real problem. So the problem statement is, you have a team of developers and you want to automate the process of code review and code execution. They want to ensure that the code is reviewed for the best practices, executed to check for errors, and then the results are reported back to the human team. So you have now, let's say in our example, 4 agents created that will do this for you. And we follow here now the AutoGen path. So at first we have 2 assistant agents. I call it Alice and Bob. Now the first, let's call it Alice, is specialized in writing the code, generating the code. Absolutely specialist on code generation. Bob has a different specialty as an LLM, as GPT-4 code assistant. He is specialized now in reviewing the code for best practices. So while Alice is focused only to write the code, Bob's only job is to be critical about the code he receives from Alice and to optimize the code. This is his task. Then, as I told you, we need here the user proxy agent. This agent interfaces with the human user. So he talks to the human operator and executes the tools. And of course, we have the boss, the group chat. This is here the manager who says, hey, who is allowed to talk? Is it Alice? Is it Bob? Do we have to get some input from the user, how to interact? So this group chat manages the flow of the conversation among the agents. 4 agents. Let's have a look at the workflow. Now, at first, initialization, all agents are initialized. Alice and Bob are configured to be backed by GPT-4 code interpreter, while user proxy is set to execute some tools or solicited some human input. Great. The task assignment. Now, who is talking with humans? The user proxy agent. So the user proxy agent receives a task from the human user to write a Python script for, let's say, data analysis. Great. Now, the group chat manager, the boss who tells her, hey, who is allowed to talk here in the group, selects now Alice as the next operating agent, based on the context that we have to write a Python script. And we know Alice is specializing in writing Python code. So Alice generates now the Python code and sends it to the group chat manager. Like, hey boss, I'm done, finished, terminated. This is the result. Now you might ask, how is this communication protocol? And this is what I'll show you in the next second. But let's just follow the workflow. So, great. Now, the group chat manager, the boss, defines now that we have the code, that Bob is now the next agent, because Bob is specialized in reviewing and be critical about code and optimize existing code. Bob does the job, reviews the code, you pay GPT-4, suggests some changes and sends it back to the group chat manager, to the boss, because only the boss is able to tell you what is next to do. Alice now also receives the code based on Bob's suggestions and sends it also back to the boss. So here, this is the main point in our network. And then the user proxy says, okay, I have access to another GPT-4 system who does code. Execute now the revised code, checks for some errors, and reports the output. The output of the code is x plus y equals z. Beautiful. We have a solution to our problem. So, user proxy sends the execution result back to the human user. Yes. Remember, he's the only one allowed to talk to the humans. And if the code execution fails and the human, like I am, says, hey, this was wrong, do it again, the task starts all over again, and this is sent back to Alice, and Alice will do its best. And you have here a multi-agent interaction of multiple LLM systems, of multiple GPT-4 code interpreter systems, or any other LLM you choose and you pay for. Great. Now, the communication is an established protocol. You notice in the good old times we had API calls between our agent, and it's still the same if you want. So in a multi-agent system like our Microsoft AutoGen, the two agents communicate back and forth, I just showed you in the workflow, involving message passing architecture, often implemented, simplest thing is an API or other communication protocols. So let's have a look at the simplest example involving some open API specification. In our example, we had agent A, Alice, and agent B, Bob, unbelievable. And both agents expose here an open API compliant RESTful API. So let's have a look. Is it complicated? No, it is simple because we have ain't a machine markup language format. So here we have it. We have now the API specification for Alice and the API specification here, as in this example, for Bob. So yes, and you have here the endpoint send message to agent B. Not gonna believe it. Send a message to agent B. You have the object and the type is a string. You get a response. Great. And for Bob, we have here endpoint receive message from agent A, from Alice, receive string successful. Unbelievable, no? Isn't it? The communication between agent with an open API specification. You can define what you want, a JSON file, whatever, a Python dictionary, a Python, whatever object you like. So, again, just to make it real clear and simple, communication flow, now that we know how it works, is both agents start up and expose their respective APIs. Then agent A, Alice, sends a message to Bob, makes a post request to agent B's receive message from agent A endpoint, adhering to the API specification. Agent B, Bob, receives the message, processes it according to its inherent LLM logic, its LLM functionality, creates a reply and decides to send this reply. So agent B is now replying. Bob makes now a post request to agent A's send message to agent B endpoint to send its reply. We have the acknowledgement phase where Alice receives the reply and processes it, possibly sending another message to Bob, thus continuing the back and forth communication between those two agents, and you define this in the master. So, simplified example, but I think it captures here, if you're not familiar, if this is the first time you look at this, captures the essence here of the two agents communicating in a system like AutoGen. If we say here in the simplest examples, they are adhering to the open API specifications. Now, the more complicated you build your system, and this will be the next video when we build upon AutoGen, but we make it better, we make it more complicated. We have here now new insights here from the last weeks and month of AI research. So you might here involve more complex data structure, the error handling, or other functionalities that you might add. So you need some advanced communication protocols. But never mind, it is simple. If you just want to understand the basic structures, it will more or less follow exactly here, this scheme. This was it, Ben. I hope this was here the insight you needed here for your open API compliant RESTful API structure. So you see the way those two or multiple agents share their data that they receive as an LLM to process the data. A result is generated. If it's an LLM, it's generated as a text string normally, sent back. So this is the communication protocol, if you want, for the communication between our 4 different agents. And you see, this is the problem. This is the agent configuration, and the result is done by simply an LLM working together with other specialized LLM. And here you have it. If you think this was a little bit boring, you're right, but never mind. Next video will dive deeper and it will get more interesting for you. See you in my next video.